Okay, in finishing up our work with radicals, we're going to solve radical equations. Now you're already familiar with solving equations. For example, when we did a linear equation, say x minus 5 equals 6, we added 5 to both sides and we decided that was x was 11. Or if we had, say, 2x equals 12, we divided both sides by 2 and said x must be 6. And the key to both those problems is that we recognize when you deal with equations that you have to treat each side of the equation the same for it to be fair. So if you add 5 to one side, you have to do it to both sides. That's called keeping an equation in balance. We also, if I may remind you, that the square root of x squared is equal to x, because the square root and the square are opposite actions. Just like adding 5 and subtracting 5 gets you right back where you were. If you square something and take the square root of it, you've gone back to where you began. So that being the case, if I had the equation say the square root of x is 5, if I square this side of the equation, I'm going to get x by itself. But just remember that you have to square both sides. So you wind up with x is equal to 25. That is how you solve a radical equation. So if it was the square root of y equals 3, you'd square both sides and say y must be 9. Or if the square root of x was 4, you'd square both sides and say x is 16. The key to this, though, going forward, because they're going to get, like everything else, a little bit more complicated, is whatever is inside the radical has to be on one side of the equation by itself. So if you were presented with a different problem, say you were presented with 3 times the square root of x is equal to 21. Since you have something else besides the square root of x on one side of the equation, you're going to have to get rid of it before you're going to square both sides. You can do that by dividing by 3 and then square both sides, and you get x is 49. You'll see this a number of different ways. For example, you could see 1/2 times x is equal to 5. Well, if we multiply both sides by 2, we'll get the square root of x is 10, and then we square both sides to get x from out of the radical. We find that x is equal to 100. Sometimes you'll have something added inside the radical. Now you have to ask yourself here, my definition is everything has to be inside the radical on one side of the equation by itself. Is that true? And in fact, in this case, that is true. So we can go ahead and square both sides, and we'll get x plus 6 is equal to 9. And then, like any other linear equation, we'll subtract 6 from both sides, and we'll see that x is equal to 3. Going on, I've got some more examples like that. Again, is everything on one side of the equation inside the the radical sign by itself? It is. We'll square both sides, and then add 5 to both sides. Now, if you see something like the square root of x minus 5 is equal to 9, different story. Now we can't say that everything on the left-hand side of the equation inside the radical is by itself. So before we square, we have to add 5 to both sides, and then we're going to get the square root of x is equal to 14, and hopefully you'll know the square root of 14 by now, but 14 squared is 196. You could see it in terms like this, where you had the square root of x is equal to 2 times the square root of 3. Now when we square both sides here, left side simple, those two cancel. Now we have to have 2 squared times square root of 3 squared, because both those are going to be squared, right? 2 squared is 4, square root of 3 squared is 3, so that means x must be 12. Hang in there with me, I've got 2 more and we'll be done. Square root of x over 3 is equal to 6. Begin by squaring both sides. 6 squared is 36. And then if you multiply both sides by 3 to get x by itself, you get 108. Last one. 2 operations underneath the radical. Same process. We start by squaring both sides. Now we've gotten rid of the radical like we like. Add 3 to both sides and divide by 2. That's it.